question for the given figure. Now this is a figure in which we have a triangle ABC which is right angled at B. AC is given as 13, AB is given as 5, the side BC is not given. We have to find sine of A, then tan of A, cos of C, and then cosec of C. So before we move ahead for calculating these trigonometric ratios, first we need to analyze this particular triangle. So I'll draw this triangle once again. So we have a triangle which is 90 degree at B. This is C, this is A, this is 13, this is 5. I need to find BC, so I let BC be equal to X. Now because this is a right angle triangle, we can apply Pythagoras theorem in this triangle. So according to Pythagoras theorem, 5 square plus x square would be equal to the hypotenuse square, which is 13 square. Therefore x square would be equal to 169, which is 13 square minus 25. X square would be equal to 144. X is equal to 12. So by calculating x, we have found the third side of this triangle. Now we will take the case 1 and case 2, because in this we have to take sine of angle A and tan of angle A. So I'll mark angle A. So for angle A, we saw earlier, for this angle A, the hypotenuse is AC, which is equal to 13. The side in front of it, which is BC, becomes the perpendicular, which is 12, and the side just adjacent to it, which is AB, becomes the base, which is 5. Now in the first part, I had to find sine of A. Now sine is the ratio between the perpendicular and the hypotenuse. The perpendicular for A is 12 and the length of the hypotenuse is 13. Therefore the answer for the first part, in which we have to find sine A, is 12 by 13. In the second part, for the same angle A, we have to find tan of A. Now tan of A is perpendicular upon base. For this angle A, the perpendicular is of length 12 and the base is of length 5. Therefore the answer would be 12 upon 5. Now we come to the third and the fourth topics, the cases where we have to find cos of C and cosec of C. Now for these two, third and fourth case, we need to pick angle C. Earlier we had picked angle A. So I'll draw this triangle once again. So in the question, this was B and we had AC, and it was right angled at B. This side was 5, this was 12, this was 13, and this we calculate out to be 12. Now we are taking angle C. For angle C, obviously AC would behave as the hypotenuse because it is in front of the 90 degree angle. Therefore AC, which is the hypotenuse, is equal to 13 units. For angle C, the perpendicular would be the side in front of it. Therefore AB would behave as the perpendicular and its length is 5 units. And the side adjacent to it, which is BC, would act as the base, which is of length 12. Now the third part had asked us to find out cos of C. Cos of C. Now cos is the ratio between the base and the hypotenuse. The base is of length 12 and the hypotenuse is of length 13, and the answer is 12 by 13. The fourth case, we had to find cosec of C. Cosec of C. Now cosec is the ratio between the hypotenuse and the perpendicular. The hypotenuse for angle C is of length 13 and the perpendicular is of length 5. Hence, cosec of C would be 13 upon 5.